Hi grade 11s, we're moving on to question 2 of our parabola and straight lines worksheet. So let's get going. So this question says, below is a sketch of a parabola f and a straight line g. P is the turning point. So the moment I see the word turning point, what goes into my head is that the turning point formula of a parabola can be written as ax minus p squared plus q. So P is the turning point of f, which means immediately I know that it moved 1 unit right, so it's x minus 1 in the bracket, and then plus 8 because it moved 8 units up. Okay, then it says f cuts the y-axis at 0, 6. Now that's perfect, because now that means I have a point on my graph. So it's very possible for me to immediately find that equation by solving for a and subbing in this point 0, 6. So f cuts the y-axis at 0, 6, and g cuts the y-axis at 0, negative 1. Okay, that's labeled on the graph, which means I immediately know that this is y is equal to x minus 1. And it says f and g intersect at b and c, where b is on the x-axis. So that's clearly a shared x-intercept. Okay, let's go read what the question says. The question says, show that f of x equals negative 2x squared plus 4x plus 6. Now, we've discussed multiple times that you can't use that answer. This, you must completely ignore it. So ignore that they have given you the answer. They've only given you the answer because if you can't do the first question, then you lose all the other marks. So we're going to ignore that, and we're going to read the question as find the formula for f of x. Now, I've already even started this because I realized that I'm clearly going to be using the turning point formula, which I've already realized I've moved 1 unit right. Remember, if you move right, it's a minus inside the bracket, and 8 units up. Now I'm going to sub in 0, 6 because that was the y-intercept. I'm not going to multiply it first because it's actually easier to substitute like this. And if I bring my 8 over, I get negative 2. Well, if I subtract 8 on both sides would be the better thing to say. And then I get negative 1 squared, which is 1, so a is minus 2. And I clearly know that I'm right because they gave that to me. Now I've also said this before. Don't now think that you have to find the b value of 4. You absolutely don't have to. You have done all the work you need to do because this is the formula for my parabola. It's just that this particular question wants it in a different format, and that format is the multiplied out version. So if I just quickly multiply it out, I know what the answer is. So I don't have to show too much working, but it's a pretty good check to see if you're wrong or right. If you quickly multiply it and get the right answer, you can move on happily knowing that you did the right thing. So I multiplied it out and I get minus 2x squared plus 4x, which means I know I'm right, and then I get minus 2 plus 8, which is 6. So if in an exam you don't get that right, you quickly go back and check to see whether you went wrong, and after a minute, I wouldn't waste your time. You might lose 1 or 2 method marks, but you'll get other marks for that question. So don't stress too much if you got it wrong, but when you move on, you must use the formula that they gave you. That's why they gave it to you. Okay, let's see the next question. The next question says, calculate the average gradient. Now, this is not something we've discussed in class, and I'm not even sure you might have done it in grade 10. So what does average gradient mean, and why does it say average gradient? The most important thing is only a straight line has a constant gradient. And that is because gradient means the slope, and only a straight line has a constant slope. So that means that only a straight line has a gradient which is always the same value. A parabola is going up, and it's quite steep, and then it kind of shallows out, and then it flattens, and then it goes down. So the gradient of a parabola is changing at all different times. So there's no such thing as a constant gradient of a parabola. It's constantly changing. So why do they say average gradient? Is because you can't tell me the gradient between 2 points on a parabola because it's always changing. What we do is we pretend there's a straight line between x is 1 and x is 3. And what we then do is we find the gradient of that straight line. So we pretend there is a straight line between these 2 points, between x is equal to 1 and x is equal to 3. Don't forget to be writing down these notes because this is how you're going to study in the future. So any average gradient, what we do is we say, right, where would x be 1? X would be 1. I know where it is. It's right at the turning point. Where would x be 3? I have absolutely no idea. So I'm just going to pretend there's a dot there. Now what they're actually asking you to do is to pretend that there's a straight line between those 2 points, and because there's no such thing as the gradient of the parabola between those 2 points because it's constantly changing, they just want you to pretend that there's a straight line there, and what's the gradient of that straight line. Now that's very easy. This is 3 very easy marks because I know the formula for gradient and it's on my formula sheet. It's y2 minus y1 over x2 minus x1. Now I know the two x values, they were given to me. They said 3 and 1. Now, fortunately, I actually know the y value when x is 1. I don't know this y value. Now, that's not a problem because I've just found out the formula. So I'm going to say, right, what is f of 3? So f of 3 is negative 2 times 3 squared plus 4 times 3 plus 6. Now, I will just use my calculator, but I'm pretty sure if I do a quick calculation that lands up being 0. Now, that means that I guesstimated where 3 was incorrectly because 3, 0 would be on the x-axis. So actually what they were saying is finding the average gradient between P and B. Now, it doesn't matter that I didn't know that. My calculation is still the same. So my y2, I'm going to say the turning point, subtract the B value over the turning point, subtract. Now, if I don't get a negative, I know I've gone wrong because this is clearly a downward sloping graph. So I normally wouldn't show this type of working because I just use my calculator, but I'll end up getting negative 4. Now that looks fairly plausible. This is also quite a steep line. If I actually draw in what line they're talking about that, and that looks fairly steep, and so negative 4 does seem fairly accurate. So average gradient questions should be questions that we get marks quite easily for. Right, on to the next question. The next question says determine the equation of G, which is the straight line. Now, that's fairly easy for me because I had already realized, no, that's not good. This is mx minus 1, and that makes me think that if I just go back here, do you see I forgot my m there? I don't know the gradient's 1, so I shouldn't have forgotten my m. So if I scroll back down, my gradient is mx, and it's clearly minus 1 because they told me that this is the y-intercept. Always be sure to never assume anything that hasn't been told to you, even if it looks like the graph goes through the axis of minus 1. Okay, now we need another point on the graph in order to do this, and I actually have just figured out a point just by luck, and that was B. I know from the previous question that B is the point 3, 0. Now, you could actually go and work out gradient using change in y over change in x, but a far easier way to do this would be to realize if there's one unknown, I'm just going to sub in a point. So when x is 3, y is 0, so I get 1 is equal to 3m, and m is equal to a third. Now, don't forget that you then need to write down the equation because that's what they asked. So it's a third x minus 1. Now, that seems probably right because that is clearly an upward sloping straight line, and it does look like a fairly shallow gradient, and so I'm happy with that, and that's another 3 easy marks. Right, onward. Next question, calculate the coordinates of C. Very common question. I'm sure you've seen this before. C, you've got to ask yourself, what is C? C is a point of intersection. They told me that it was a point of intersection. Now, I know one of the points of intersection already. Just by luck, I know that B is 3, 0. So if I work out the points of intersection and I don't get one of them as 3, again, it's a bit of a self-checking. I can see I've done something wrong. Now, I wrote these notes in the previous question as well. A point of intersection is where the two graphs are equal to each other. So I'm solving a little mini simultaneous equation, except that it's quite an easy simultaneous equation because I have the two equations. My one equation is minus 2x squared plus 4x plus 6, and I've just worked out that my other equation is a third x minus 1. Now, your teacher will method mark everything that you do, and so it doesn't matter if you got the straight line incorrectly. Still solve this question because you can get method marks. Now, personally, I don't like this fraction. I really don't like a third x. It would bother me. So what I would do, just to make my life easier, is I would now multiply every single term by 3. Just because I don't like fractions that much. It isn't the only way to do it, but I would find it the easiest way. So I get minus 6x squared plus 12x plus 18 equals x minus 3. Now that's a fairly standard quadratic equation, which means my ways to solve quadratic equation is get one side equal to 0. Personally, I would put everything on the right hand side just so I had a positive coefficient of x squared. So it's minus 11x minus 21, I think. Now, if you don't like those numbers because now you've got 6 and 21, I already know one of the answers. I know that 3 is one of the answers. So maybe that'll help me a bit. So immediately I'm thinking, do I use 3 and 7 for my 21? Then do I use 6 and 1? Do I use 3 and 2 for my 6 and 3 and 7? Now, if you start to get a bit tired of trying to factorize, you can always use the formula. If you do decide to use the formula, just don't forget to show your substitution. I'm not going to bother because I think I've figured out that if I go 6 times 3, I'll get 18. And if I go 1 times 7, I'll get 7. And I know I can subtract those to get 11. So if I just set that up, I think it's going to be 6x and x. And I want to multiply 6 by 3. And I want that to be a minus 18 and plus 7 to get my minus 11. So I then know that x is equal to 3, which I was expecting. Or I know that 6x plus 7 equals 0. So 6x is equal to negative 7, and x is equal to negative 7 over 6, which is just less than negative 1. So if I go and look at the picture, does that look plausible? Yeah, it's in the negative region. So a negative answer is quite expected. Now, just make sure you answer the question. The question said the coordinates of C. This is not a coordinate. So I need to therefore say that C is negative 7 over 6, and I need my y value. Now, the easiest way, I think, would be to go and substitute this x value into the straight line, simply because the parabola is more complicated, so I would go and put it in there. Now, for some reason, my one... Oh, sorry, not in there. That's incorrect. I was about to say that's not the right equation. I need to go put back into my g of x. So if I just do this on the side, what is g of negative 7 over 6? And I would use my calculator because it's got fractions and I'm feeling lazy. So negative 7 over 6 minus 1. Okay, I used my calculator and I got negative 25 over 18. Don't be afraid if these numbers are not perfectly lovely whole numbers. Sometimes it's quite hard to make up questions that have lovely whole number answers. Right, and there's my point of intersection, very commonly asked question. Right, on to the next one. The question says, if h of x equals f of negative x, explain in words the transformation from f to h. Now, I don't even have to know what this function looks like at all. Basically, what happens is you're taking Freddy, so I'll call these things Freddy, you're taking f, which I will call Freddy, and you're making x into a negative x. So if you're changing the sign of x, what transformation is that? And that will be a reflection over the y-axis. So this is a reflection over the y-axis. Now that is something you just have to know. If you're changing the sign of x, you're reflecting over the y-axis, and then the opposite is also true. If you're changing the sign of y, you're reflecting over the x-axis. Now it said explain in words the transformation from f to h and give the equation of h. Well, there's my explanation in words, and now I have to give the equation of h. Now if I just go back to what f's equation was minus 2x squared plus 4x plus 6. So f of negative x, which we now call h of x, would be negative 2, and every single time you see x, you put a negative x. Every single time you see x, you put a negative x. So that's what you do to the equation. Instead of having x, you have negative x. Now, this actually can simplify because negative x squared is the same as x squared. But this second term is now minus 4x and then plus 6. So just note, please, 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 that this negative x needed to be in a bracket because then you were squaring it. So that's h's new equation, and it was a reflection over the y-axis. Right, on to the next one. For what values is f of x less than g of x? Now, again, we've discussed this countless times. This always centers around these 2 points of intersection. So just to remind ourselves, that happened when x is 3, and this happened when x is minus 7 over 6, if my memory serves correctly. Now, this question says, when is the parabola, when are the y values of the parabola less than the straight line? So I've said this before, but what I do is I put a ruler, well, if I actually have a ruler, I put a ruler on the side of my graphs and I say, right, what do I want? I want the parabola to be less than. So if I start over here, who's less than? And oh my word, it is the parabola. So everywhere here the parabola is less than until they hit each other. Then what's happening here is the parabola is bigger than the straight line, bigger than the straight line, bigger than the straight line, bigger than the straight line. Then they're together, and now the straight line's bigger, the parabola is smaller. Now I wanted a smaller parabola. So what this means is it's those two regions. It's from this point of intersection upwards, the parabola will be less than, and from the C point of intersection downwards, the parabola will be less than. So those values are x is less than minus 7 over 6. So that's that region there, not equal to minus 7 over 6, because the question didn't say that the graphs could be equal, or x must be greater than 3. Now I've said or because when you have two intervals like this that aren't one interval like in the previous question, the answers have to be two separate intervals, because you're either in that region there below C, or you're in that region above B. You can't be in both regions at the same time. They're two separate regions. Hence, if two separate regions are occurring, we always use the or between the inequalities. Right, on to our next question. Very common type question. We've done one of these before, and this is a vertical distance question. Now remember what I've said before, vertical distance is always top y minus bottom y. So that's the most important thing to remember. Vertical distance, top y minus bottom y. Now, in the previous question, it was a fairly easy question. This one is the much more difficult version. This says T is a point on F, and S is a point on G, such that ST is perpendicular to the y-axis. That should say the x-axis for sure. There's a typo. That should be, say, perpendicular to the x-axis. Reason why it says that, remember, is to just tell you that that is a perfectly vertical line, and it lies between the points of A and B. So they're telling you it lies between the points of A and B. The reason why it has to tell you that is you have to know which of the graphs is on top. And so in this case, you know that the parabola is on top in this region. So your top y is going to be the parabola. Now it says determine the maximum length of ST. Now before we even think about the maximum length of ST, let us go and find out what ST is equal to. ST is a vertical distance, which is top y minus bottom y. Now in the previous question, this was an easy version of the question because you knew the top y and you could work out the bottom y, and so you could subtract. I don't know this top y value because I don't know where t is. So the only thing I know about this top y value is that it is negative 2x squared plus 4x plus 6. That's the expression for that top value. If I knew what x is, I could put in x and I could actually find an answer. Then minus, now I don't know this y value because I don't know where s is, but I do know that that y value will have the expression a third x minus 1. So if you knew these x's, you could actually know these values, but I don't, and so I use the expression. Now, what I need to do is simplify this into one nice little neat expression. Now, what I cannot do now is what I did when I was trying to solve the point of intersection. I can't multiply by 3 because this isn't an equation. So you can't multiply by 3 because there aren't two sides. It's not an equation. This is just, I'm simplifying an expression. So it means that I'm going to have to use fractions. They're not terrible. We can use calculators if you want to. So it's minus 2x squared. Now 4 take away a third is 11 over 3. You can do that in your calculator. And 6 plus 1 is 7. Now that's an expression for ST. Now that's wonderful. If I knew what X was, I could actually tell you what ST was. So if now they told you that, I don't know, X was 0, then I could sub in 0 and I could actually work out this distance from S to T. But I don't know where this X value is. Now this is the most difficult thing to understand. This is a formula that tells you the length of ST. So this is a formula to tell you the length of ST. Now, if you look at this formula, it actually represents a parabola. So if you plotted the length of ST, it would be like a parabola. Now, even more than that, it would be a sad parabola. And so the length of ST definitely has a maximum length. This parabola that I've just drawn represents the fact that ST is a quadratic function, and therefore if you graphed it, it would be a parabola. And every parabola has a turning point, and in this case it's a maximum because it's a sad parabola. Now this question said determine the maximum length of ST. So I'm trying to maximize this ST. And where does the maximum occur? At the turning point. So therefore I just need to be able to tell the turning point of this ST expression, and I've answered the question. Now, how do we find a turning point? Well, there's multiple options. The easiest way at grade 11 level is to use the cheat, which is negative b over 2a. At grade 11 level, that's the easiest way to do it. So b is 11 over 3, so it's negative 11 over 3 all over 2a, which is negative 2. Now again, I just use my calculator. I wouldn't bother showing any working. So my X value of my turning point is, it's 11 over 12. So this particular ST, this expression, when X is 11 over 12, it'll maximize this ST. Now we still haven't answered the question because it didn't say at what X value will it maximize. It said what is the maximum length. And so what I still need to do now is I need to go to this expression of ST and I need to actually sub in my X value. So I now know that I'm looking for the vertical distance at 11 over 12. Now I'm not going to go and bother finding top wide 11 over 12 and bottom wide 11 over 12 because I have this expression for the distance already. So I'm just going to sub it in, pop that into my calculator and work it out. Now I just forgot this little squared up top there, which I just realized. Now I've put that in my calculator and I get 625 over 72. Now I have no idea whether that's right or not. If I change it to a decimal, I get 8,68. Now that seems kind of plausible because if I scroll up, the turning point is at 8 and then this would have been, fairly below that. And maybe the maximum distance occurs about there, and so yeah, it'll probably be just over 8 units apart. So don't be thrown off by numbers that aren't perfect. There's nothing wrong with rational numbers that are fractions. Nothing wrong with that at all. Okay, now that's definitely the most difficult way to ask a distance question, is to ask you to maximize the distance. So we'll definitely practice one of those again. Right, now on to the last question, which is more of a problem-solving question. It's similar to the one that we did in the first question, which is about this whole value of k business. So this question says, for what values of k will f of x equal to k have, now what does that mean again? Remember that k is just a constant. So they're saying, what constant would you need to have so that the graph intersects that y value, and then it says to you, the first one says no real roots. So that means never. Now remember what I said in the previous question, if I draw a random horizontal line in, let's say that's at about 5, there are 2 places where this graph equals 5. If I draw another one, there's 2 places where this graph equals about 2. Now you on the first question are looking for where there is no place that the graph hits a line. Now if I draw a horizontal line that hits the turning point, there is 1 place where the graph goes through 8. Now anything above 8, the graph will not hit at all. So when k is greater than 8, your parabola will never get to that level. And so in this particular question, if you want no real roots, you need k is greater than 8. There's no time that the graph will get up to above 8. Now, these are all related. All these questions about k are generally all centered around the turning point. So the next question says, what values of k will allow for one root? Now, I've kind of already said that. There's only one place a horizontal line can be if you're going to make sure that it intersects the graph only once, and that is if k equals 8. So if you drew a horizontal line at 8, the graph would only intersect it once. Now, when it says it wants 2 real roots, anywhere below that 8, your horizontal line would hit the graph twice. So as long as k is less than 8, you would have 2 real roots. So we don't often ask all 3 of these. We will pick one to ask in a test, and they're quite problem solving. But as long as you try and use the horizontal line idea, and you remember that it's largely got to do with the turning point, you'll be alright. Okay, and that ends question 2.